All right, Geometry Standards, Geometric and Spatial Reasoning, Standard 4.5. Angle relationships. And what we do is name these angle pair if we have two lines M and N with T called a transversal. So if we cross two lines, we have these various angle pairs. We'll name those. Now, vertical angles we've established in the previous video, those are opposite in the X. We have four pair here, 1 and 4. Okay, again, opposite in that where two lines cross. 6 and 7, 2 and 3, and 5 and 8. And regardless of the status of M and N, these vertical angles are always going to be congruent. Also have corresponding angles. Now, corresponding is a word you're going to hear a lot of times in geometry. It means in the same location. So 1 and 5, if you look at this cluster and this cluster, 1 and 5 are each in the upper left-hand corners. So they're corresponding. 2 and 6, upper right-hand corners, and so forth. 3 and 7, 4 and 8. Now, if M and N are parallel, then corresponding angles are also congruent, like vertical angles. Okay, so vertical angles don't need need the lines to be parallel, but corresponding angles do need the lines to be parallel for the angles to be congruent. Okay, we also have alternate. Okay, alternate are opposite sides of the transversal. 1 and 8 are what we call alternate exterior angles. Now, exterior would be not between the lines. Okay, so between M and N is the interior. On either side of M or N is the exterior. 1 and 8 are both exterior and on opposite sides of the purple line. So are 2 and 7. And we call 3 and 6 alternate interior, okay, because they're both inside. And 4 and 5 the same thing. Again, if the lines are parallel, then alternate angles are congruent. We also have same side. Okay, same side of the transversal and either both interior or exterior. Okay, you can't have one of each. It's got to be either both interior or both exterior. So 1 and 7 are both exterior on the same side of the purple line. 2 and 8 are same deal. 3 and 5 are both on the same side, but they're both interior. And so is 4 and 6. Now you can tell with these lines, just looking at it, that 4 of the angles appear to be obtuse and 4 appear to be acute. Okay, so it's pretty clear just by looking at this that 3 and 5 are not congruent, nor are 1 and 7. They're actually supplementary. Okay, if the lines are parallel. We've already established linear pair. Those are two angles, should say two adjacent angles that make a line. 1 and 2 are example. 5 and 7 are an example, side by side, and there are 6 other pairs. Linear pairs also supplementary, regardless if the lines are parallel or not. Okay. The first example, let's find the other 7 angle measures. And again, if these lines are parallel, now you're not told, we're going to say that the lines are parallel here. If the lines are parallel, then there's only 2 distinct angle measures. Again, they're not marked, but that's part of the instruction. They are parallel lines. Okay. So we're going to say that measure of angle 8 is 65 because these are vertical. Now, it doesn't matter if they're parallel or not, 8 is going to be 65. 2 is 65. Okay, what kind of angles are 65 and 2? They're corresponding. They're both in the bottom left-hand corner. 4 is 65 because they're alternate. Okay, remember, they're both exterior on opposite sides of the purple line. Now that's 3 of the 7. Let's go to the others. Measure of angle 7 is 115. Now, where 115 comes from is simply subtracting from 180. These are linear pair. Doesn't matter if the lines are parallel or not. Linear pairs are always supplementary. 5 and 65 are also linear pair. Then we have angle 1. That's same side exterior. Okay, remember, same side would mean both on the same side of the transversal and both being, in this case, exterior. Now, measure of angle 3, there is no name for 3 and 65. It's the only angle that doesn't have a named relationship with 65. But it's also 115. And simply, you could say it's either corresponds to 7, or it's vertical with 1, or alternate interior with 5. Second example, here we'll find the value of x. Again, these are marked parallel. Now, what kind of angles are these? They're corresponding. And corresponding angles are congruent. Yeah, but remember, there's only really congruent or supplementary. That's your only options if the lines are parallel. And you can usually tell by looking. These look like they're both acute. Okay, so you simply set those equal to each other and solve for x. Add 2 to both sides, divide by 11. Okay, a third example, again, they're marked parallel. What kind of angles are these? They're same side interior. Okay, both on the interior, both on the same side of transversal. So they're supplementary. You add them up to 180, so it's a different look. Add your 2x's and your 43 minus 3 to get 4x plus 40. Subtract 40 from both sides and divide by 4. Of course, you can pause if you need to have that go a bit slower. All right. Now with parallel lines, we can easily prove the triangle sum theorem. Okay, so if we'll notice here, we've got these three angles, 4, 1, and 5, and 4, 1, and 5 obviously make 180 degrees because they're all on the red line. Well, 4, if we add in there that this red line and this black line was made to be parallel to one another, then 4 and 2 would have to be congruent because they're alternate interior between the red and this bottom line. Similarly, 5 and 3 are alternate interior. Okay, so 5 is basically 3 and 2 is basically 4. So if we say 1, 4, and 5 all add to 180, that's the same thing as saying 1, 2, and 3 all add to 180. If you notice, 1, 2, and 3 are all the three interior angles of the triangle. And that leads us to the three interior angles of a triangle add to 180 degrees. So quite famous theorem. It's pretty easy to prove here. So fourth example, we've got these three expressions. Find x. Here you're always setting them equal to 180. You're adding them all three up and setting them equal to 180. So similar to the previous problem, add your x's. 7, 2, and 5 make 14. Negative 11, negative 3, negative 2 make negative 16. Add 16 to both sides. 180 plus 16 is 196, and divide by 14. So x is 14. One more kind of offshoot of this is the exterior angle theorem, which I won't prove here. It's not hard to prove, but this orange angle BCD here, is an exterior angle. It's an extension of a triangle on the outside. B and A are called the remote interior angles to that. Okay, the remote interior means not the interior angle that's adjacent right beside it, but the other two. Okay, and the rule is that the orange is equal to the blue plus the green. Or, in words, an exterior angle to triangles is equal to the sum of the two remote interior angles. Okay, so looking at the application there, the setup for this, make sure you get the exterior angle on the outside. Okay, so 20x is the exterior angle, this angle ABD here. It needs to be by itself. Okay, add the other two. 5 and 60 make 65. Now let's subtract 7x from both sides. Divide both sides by 13. Remember, pause if you need to. Now 5 is not our answer. We're looking for the measured angle C. So I'll insert 5 into the x position to get 40 degrees. Our standard says use geometric reason to establish facts about the angle sum and exterior angle of triangles, about angles created when parallel lines are cut by transversal, and the angle-angle criterion for similarity. Now, angle-angle criterion for similarity I think is better for the next section. We have a whole unit on similarity, so we'll discuss that aspect later.